Hello everyone, it's Dr. Wolfe here, and in this video, I'm going to be going over number 2 on page 19. So here we have a heterozygous mom and a heterozygous dad. They both have brown hair. What are the chances their kids will have red hair? All right, brown hair is dominant. And by the way, we could figure that out just by knowing that if they have brown hair and they're heterozygous, that the brown hair is dominant. So first thing I want to do, make a key, right? Big A, little a. And you know what? I usually do A's, but let's do B, right? Uppercase B is going to be for brown hair. Lowercase b is going to be for red hair. All right, next thing I want to do is just add in the genotypes of the both parents. All right, again, I could put the dad here, but I could also put the dad here. It doesn't matter. So let's just put the dad to the left side just to show that we can mix it up. So the dad is heterozygous, which means big B, little b, dominant and recessive. Same thing with the mom. All right. Heterozygous, dominant allele, recessive allele. Right? So now we're going to do the cross. Mom passes down the dominant, dad passes down the dominant. All right, mom passes down recessive, dad passes down the dominant. All right, mom passes down dominant, dad passes down recessive, and then both are going to pass down the recessive in this box right here. All right, so what are the possible genotypes? Every single genotype is possible in this cross, right? You could have homozygous dominant, big B, big B. You could have heterozygous, big B, little b. You could have homozygous recessive, little b, little b. All right, now let's look at the possible phenotypes that we could get. Well, if you have the dominant allele, you're automatically going to have brown hair, right? So then do we have any combinations or any genotypes where there's just the recessive? Yes, little b, little b. And so there is the possibility that the kid could have red hair. So what are the chances, though, of having these genotypes or having these phenotypes? All right. For the genotypes, right, I'm going to look here and say, okay, well, how many boxes are big B, homozygous dominant? And it looks like there's just 1 out of 4. So that's 1 out of 4. I could put 1/4. You could absolutely put a fraction. You could also put 25%. All right. Notice how I did percentages up here, fractions up here. I'm fine with either one. Well, what's the percentage that they're heterozygous, that the kids ends up being heterozygous? So I have 1 box that's heterozygous, 2 boxes, so 2 out of 4. So that's 1/2. That's a 50% chance. You could put in percentages as well. And then what are the chances that they're going to have little b, little b? All right. Homozygous recessive, 1 out of 4 boxes. Again, I'm counting up these 4 boxes right here. So that's 1 out of 4. All right. And then let's look at the phenotype percentages. All right. So for brown hair, right, how many boxes do I have with an uppercase B? And you don't have to shade these in. I'm just doing this for the video. All right, but I have 3 boxes that have the dominant allele. All right, so that's 3 out of 4. So that means there's a 3/4 chance or a 75% chance that they're going to have brown hair. But there is a 25% chance, a 1 in 4th chance, right, that they could have a kid that has red hair, even though they don't have red hair. They have brown hair, right? They're carriers, which means that they carry the gene for red hair, even though they express the dominant trait. All right. So I think this is a great example of how you could have different percentages of genotypes and then have different percentages of phenotypes, all right, based on the cross.